come from about 25 years in the industry, working with fabric construction, and then the last 11 years, I've been running Bravo Lab as a consulting company, everything from engineering, design, and material acquisition to training. We started here in January of 2021. Peter drew me to this project because he has a very strong vision as to what he is looking for. What he wants MJM boats to be are efficient, light, stiff, maneuverable boats. The DNA that Peter set forth for us was very clear. Lightweight, high quality laminates, top of the list. Make every gram count for something in the boat. No parasitic weight. Off went gel coat, skin coat, and the decision was made to paint the hulls. Right after that, we decided that an epoxy infused hull was going to be preferable because we could shed quite a bit of fabric weight. In an epoxy infusion, the adhesive is much stronger than a vinyl ester, so we can eliminate all the chopped mat on the backs of the fabrics. So this is a good example of a complex geometry and a laminate that's making every gram pay for itself in terms of the strength of the boat. This was infused in one shot. Some insight into how fabrics work going around corners, into cavities, and then how do we wet this out in a very systematic fashion so we don't get any dry spots within the laminate. So we basically went back to ground zero and we re-engineered all the laminates based on a quadraxial hull reinforcement, which means we have equal strength on all axes, 0-90 plus minus 45. So we don't have anywhere in the hull where resin is by itself carrying the stress and carrying the loads of water pressure, for example. So based on that, we were able to meet ISO standard Class B, which is for coastal use. We're able to meet all of the criteria in terms of fiber resin ratio. Our laminates are about 70% fiber, 30% resin. So we have very low void content. It also enables us to compact the laminates more than having air trapped in the laminate. So this gave us a weight advantage, but most of it gives us a stiffness and strength advantage. We're able to increase our compression strength, which is the weak link of any laminate. We're able to increase that because we have such a low void content. What draws me to this project is the fact that we're essentially went after the weight, stiffness, strength, and cost, the four things that drive any composite laminate, whether you're building a bathtub or a Boeing 787. We went after each of those and said, how can we optimize the laminate to the point that if you were going to build a custom boat, really would there be any advantage? And so we treat the deck, the grid, and the hull with that philosophy, that we're going after every aspect of extra weight, whether it's in the fabric or the resin, because it doesn't help the strength of the boat. It doesn't make the boat any better to have a resin-rich laminate. Fiber being much stronger than the resin that holds it together, it's to our advantage to drive the resin down, providing you have good vacuum. Everything we do is driven around having an efficient vacuum system, and to that end, we spared no expense with vacuum pumps that have high capacity. We're getting some exceptional vacuum pressure and very low leak rate. So we're able to build something that most people are unable to do, because we launched into this not starting with the bottom up kind of, what do we have for equipment? Yeah, we have a bunch of old pumps and hopefully they'll run through the day. No, we started with brand new equipment. We started with the optimum equipment. We just installed an oven with the absolute best heat exchange method and 26 thermocouples on the inside and outside the hull, because it's a forward hull, so you need to measure post-cure on both sides. This is the kind of stuff that an America's Cup construction might be looking at. In fact, we have team of people working with me who were involved with America's Cup parts and boat construction. So I learned from them, and I bring that to the table with Peter, and then we go ahead and we decide, is this something that makes sense on a production scale? So this is a good example of how moving from open molding and even vinyl ester infusion, we're able to affect about a 30% weight saving by using infusion, epoxy, and a structural fabric like a quadraxial without having the chop mat on the back. So about a 30% reduction in final weight is something that you can't achieve any other way. There's no way to take that weight out of the boat without making a compromise to the stiffness and strength. We have an epoxy system where after 24 hours sitting in the mold at 70 degrees or so, it's stable enough to demold the boat. Now when we stick it in the oven, we have 26 thermocouples on the inside and outside of the hull. Now we can fully post-cure the boat because there's nothing preventing the heat from reaching the laminate. So it's where the boat will gain its final amount of stiffness and strength. That's something you're going to notice from a performance point of view. So this is an example of infusion working as intended. The fact that there's a 35-ounce quadraxial on here that you can't see is an indication that both the epoxy and the pressure from the vacuum bag is working as intended. 1 atmosphere of pressure from the vacuum is equivalent to 2,016 pounds per square foot pushing on the inside of the mold. But the clarity that you see here is a good indication that everything's working according to plan. One of the first things we did in January and February, we had some tooling which needed to be worked on, but we did have 2 deck tools. Decks are not just the deck, but it's 90% of the interior as well. So it's extremely complex from a geometry point of view. Most production boat builders do not infuse the deck because of this immense variety of geometries to deal with. But we had a team of people with good boat building background, and we got together and we said, how can we make this happen with the minimum of risk? On the first deck, we had 90% success. So to be able to infuse an epoxy deck on top of a vinyl ester skin coat, we did a lot of lab testing with the epoxy supplier until we're absolutely sure that we would not have a problem of bonding those 2 surfaces together. But today we build and infuse grids and decks, which are much more complicated than building a hull. We are able to take advantage of lightweight, taking full advantage of the laminate design and the fibers. And we're able to build a very light, stiff, strong deck that way.